Hi students, let us play with physics. Now today's topic is, we are going to learn about what is meant by terminal velocity. Okay, now let us take a jar, a tall jar, which contains a highly viscous liquid. Now I am going to drop a metal ball. So a spherical metal ball is dropped here. Here the weight of the metal ball is acting downward. Now, if this weight is balanced by two other forces which are acting opposite to that of the weight, then the metal ball or the spherical metal ball will travel inside the liquid, that is highly viscous liquid, with a constant velocity at different points. So that constant velocity is called as the terminal velocity, right? Now, what are the two forces acting opposite to the direction of the weight of the spherical metal ball? So, I'm going to use the mnemonics. W is equal to Phy, right? F plus U, and this F is called the viscous force and U is called upthrust or upward force due to buoyancy. Okay, how can we understand these two forces? Now I am going to take the liquid as different layers like this. Now this is compared with, I'm going to have so many number of thin fine cloths which are bundled together and kept on each other like this. So this is compared with the different layers of the liquid. Here the liquid is a highly viscous liquid. So these are the fine cloths, the different layers of fine cloths which have been kept on each other like this, very closely packed like this. So like what we have seen here, the different layers of liquid, right? Now when I drop a metal ball on this, so each layer will be bent like this, so will form a depression like this. Likewise, whenever a metal ball is dropped here, the different layers of liquid forms like this. So these different layers of the cloths will prevent or will try to balance the metal ball here. Likewise, these liquid layers try to balance the metal ball in order to prevent or make the metal ball to move slowly like that. So that is what we call as the viscous force of the liquid layers. Now, what is upthrust? Here, there are so many number of molecules present in the liquid. So each molecule will offer some upward force or opposite force to the movement of the metal spherical ball. So that is what we call as the upthrust due to buoyancy. Here also the molecules of the cloths, the different layers, will offer some resistance or will oppose the movement of the spherical ball. So if these two forces are in this liquid which opposes the movement of the metal ball, and if these two forces are equal to the weight of the metal ball which is acting in the downward direction, so we know that W is equal to mg. So if these two forces are equal, then the metal ball acquires a constant velocity and it moves with a constant velocity inside the liquid. That is what we call as the terminal velocity. As you all see, in the space, the water droplet, there are so many water droplets present in space. And due to the smaller in size, the droplets are smaller in size, right? So due to the smaller size, the droplets, they move down. The weight of the droplets will be acting downward, but it will be kept balanced in space itself because of the smaller size. Now, when these water drops combine, so when so many number of drops combine together, and if they grew as a bigger size molecules combine together, then they attain a terminal velocity, so they drop as rain. So this is because of the terminal velocity. So smaller the size of the droplets, smaller will be the terminal velocity, due to which it is balanced in space itself. The bigger the size of the droplets, greater will be the terminal velocity, due to which it is dropped as rain. So this is one of the example of terminal velocity. Thank you.